Greetings to all of you. The session is regarding intermediate chemistry. We'll be fetching for your international entrance and competitive exams as well. India is conducting IIT and NIT admissions through JEE Advanced and the JEE Mains examination all across India. That's the technical domain. NEET exam will be conducted for medical stream all across India by National Testing Agency, and this is for medical entrance. Telangana and Andhra Pradesh government are conducting MCET examination for engineering stream. That is again technical domain, BTech entrance examination. In addition, if you are aspiring for any competitive examination, you are writing any government job related examinations, there general studies common paper will be observed. In that, general science content will be there. The topics what we are discussing, what problems what we are solving are very much fetching towards that kind of preparation. Let's enter into our informative session. Identify the isomerism in the following complexes, right? So this kind of isomerism can be identified for the given coordination complexes, right? Here is the cobalt complex, which is in the sphere of 6 coordination complex. Here you can notice 5 amino ligands and 1 chloroligand is there inside the sphere, and one of the bromo is there outside the sphere. This is one of the condition. And in the second one, there is a exchange of chloro with bromo and vice versa. So that bromo is came into the sphere, chloro is indicated here. So this is the way two compounds are mentioned. Both are having exactly similar molecular formula except the arrangement of these two. This is said to be what kind of isomerism in the context of coordination complexes. In order to explain the content which is collected from the Liber text, here it is the part of structural isomerism. Structure of the complex got slightly modified, but the molecular formula remains same. And here in specific, this is the part of ionization isomerism. Ionization isomerism occurs when ligands that bound to the metal center exchange their places with the anion or else a neutral molecule originally outside and outside the coordination complex. Exchange of ions is possible around the central metal by means of outer to inner sphere or else inner to outer sphere. This is possible by means of ionization isomerism. Here is the simplest example: chloro with bromo is exchanged inner to outer sphere like this. This is the way ionization isomerism is explained in this complex. This is possible whenever ionizable ions can be replaced, that might be neutral or else negatively charged, can be exchanged from outer to inner, inner to outer coordination sphere. So this is the example. These two complexes are the example for ionization isomerism with the same molecular formula, but only there is a structural modification due to the exchange of ions in the coordination complex. That is said to be ionization isomerism. So that question number 1 correct answer is ionization isomerism. This is collected from Liber text. Now let's move on to question number 2. It is collected from Cambridge Assessment International Education, where it is the part of volumetric analysis. Everybody aware about the burette, pipette, burette, conical flask, and it is the liquid taken in the conical and another liquid placed in the burette. Burette is filled with the dilute sulfuric acid, as they said, and sodium hydroxide was taken 25 cubic centimeter in this, and drops of indicator is also mixed up. Then it's volumetric pipette used to measure 25 cubic centimeters of 2 moles per decimeter cube, right? So it is the 25 is the volume, we can say centimeter cube volume, and 2 moles per decimeter cube is the concentration. This is called molarity. Aqueous sodium hydroxide into a conical flask. A burette is filled with dilute sulfuric acid. Being it is the kind of aqueous sodium hydroxide which is titrated against sodium hydroxide, simple neutralization reaction carried, which is mentioned with the chemical equation. Sodium hydroxide, sulfuric acid got neutralized to give salt and water. Sodium sulfate salt will be formed and water is discarded. This is the way neutralization reaction got carried. In this, A reaction requires 50 cubic centimeter of dilute sulfuric acid to reach the end point. 50 what cubic centimeter volume got consumed. What is the concentration of dilute sulfuric acid? A dilute sulfuric acid concentration to be depicted. Volume of NaOH is known. Concentration of NaOH is known. Volume of sulfuric acid is known. Concentration of sulfuric acid to be calculated. So this is possible by simple formula which is given as M1V1 is equal to M2V2. M1V1 terms belongs to sodium hydroxide, let's assume. M2V2 terms belongs to sulfuric acid. M1 is called concentration of sodium hydroxide. V1 means volume of the sodium hydroxide. M2 means concentration of sulfuric acid solution, and V2 means volume of sulfuric acid solution. Here, everything is known to you. All the numerals are provided except the concentration of sulfuric acid. So that let's go with the concentration depiction. Concentration of sulfuric acid is equal to M1V1 by V2. In order to calculate concentration of sulfuric acid, molarity of NaOH, volume of NaOH by volume of sulfuric acid to be taken. Molarity of sodium hydroxide is given as 2. Volume of sodium hydroxide is given as 25. Volume of sulfuric acid is given as 50. This data entirely provided within problem only. This data is there. 25 multiplied with the 2, 50 is the value. 50 upon 50, that will become 1 mole per decimeter cube. 1 mole per decimeter cube is mentioned in the option number B. For question number 2, option number B is the correct answer. This is the volumetric analysis based question, titration based question. Move on to question number 3. Question number 3 collected from JEE Advanced 2018 paper 2 question paper. And it is purely related with organic chemistry, in specific stereochemistry. For the given compound X, how many total number of optically active stereoisomers are possible? In order to calculate the stereoisomers, first of all, we have to know how many chiral centers are present in the compound. Chirality denotes what? The number of carbons which are accompanied by 4 different functional groups around is called a chiral carbon. If you see this carbon, here is the possibility of chirality, which is denoted with a star at asterisk mark. And here is the OH, and here also you can notice the chiral center, here also chiral center, here also chiral center. This type of bond indicates that configuration with the specific carbon geometry of the double bond is fixed. Which bond? Wedge bond. Here is the wedge bond, you can understand. So it is the fixed bond towards the viewer. And whenever bond is represented with this curved one, this type of bond indicates the configuration specific carbon. Geometry of the double bond is not fixed. So geometry either towards the viewer or else outside the viewer. Any of the condition may be feasible, that is indicated with the curved bond. So both the bonds are represented over here. This is the wedge bond, this is the curved bond. At that condition, how many optically isomers are possible? That are number 7. 7 in the number are possible. Let's see how can we explain this. Whenever you go with the compound where we are having OH, here the possibility of this OH, let me put this OH towards the viewer. Again, it is mentioned wedge bond. So there is a provision. So if the curved bond is there, there is the provision to indicate towards the viewer, right? If you are indicating towards the viewer like this, what happens? All the bonds are indicated towards the viewer. There is a perfect plane of symmetry in the molecule. Whenever perfect plane of symmetry is present, the molecule itself becomes optically inactive. The condition for optical activity will be symmetry elements must be absent. Here plane of symmetry is observed in the molecule. You can cut the molecule exactly half. 2 equal halves are possible, which is called horizontal plane of symmetry. So here horizontal plane of symmetry indicates the compound is optically inactive. This is the essential condition. If symmetry elements are absent, molecule is optically active. Here is the symmetry element. We have plane. Just we put the plane over here, above half, below half are identical. So that optically inactive. Move on to another possibility. Let me throw this OH back end. Being it is a curved bond, it can be taken back end. Whenever it is back end, what happens, though you're putting the plane over here, that may not cut the molecule as a equal half, so that no plane of symmetry, no symmetry elements, and it is said to be optically active. And one more condition I may have, entire this branch is taken back end. So this wedge bond now, because we have a curved bond, right? That curved bond can be depicted with the wedge bond. Wedge means the entire moiety going back in. Whenever this is entirely moving back, what happens if you are putting a plane over here, that may not cut the molecule equal halves, so that optically active. No plane of symmetry, optically active. So how many you counted? 1 and 2. So this is not regarded. So, and move on to this wedge bond, and this is also wedge bond. Two probabilities you can notice, so that it is also optically active, because unsymmetrical molecule, no plane of symmetry, optically active. And one more possibility you can notice, this is the wedge bond, and this is the wedge bond with the OH towards any other edge. Being it is a single bond, can be twisted, right? There is a kind of conformation. Here OH is coming this side, P is this coming this side, so that this is a kind of conformational isomerism, you can say. This is another kind of possibility, another stereo location you can notice. And again, it is a kind of optically active, so that no symmetry element in this. And if you go with same OH, wherever twisted, can go back, so be with the dotted line bond, so going back end, so it also the another possibility of isomer with the optical activity. So this is another possibility. What we used to do in these two, just we twisted the bond, being molecule, any molecule is rotated along the carbon carbon single bond, is called conformational isomerism. These two isomers are due to the conformational isomerism. One is towards the viewer, and either is back end the viewer, right? So move on to another possibility. Same OH placed over here can be represented whenever this bond, the bond which is linking with the cyclic ring, can be taken wedge bond. So here we have a thicker wedge bonds. Here it is taken as a dotted line bond, but representation remains only. Here is the change you can notice, so that OH is towards the viewer, OH is back in the viewer. This is 1, this is 2, this is 3, this is 4, this is 5, 6 and 7, but it is not the optically active isomer, so that 7 isomers are possible, you can notice. For question number 3, option number 7 is the answer. Correct answer will be the 7. This is due to the location of OH. These two possibilities can be changed. These two OH we are going to change up, so that these many 7 isomers are possible, with the chirality, optical activity. Fine. Move on to question number 4. Question number 4 is a part of organic chemistry again, with the physical chemistry perception, right? Organic chemistry can be dealt with the physical chemistry analytical methods, right? So that here organic molecule sequence reactions can be conducted. First of all, we have to know which reagent, what product we are going to get through the series of intermediates. After getting the final product D, we have to go for the calculation of percentage of yield. Two problems are hidden in this. One is organic chemistry part. After getting organic reactions, we have to go for analytical part, that is the percentage of yield to be calculated. To do this, let me read the question first. In the following reaction sequence, amount of D means a final one, anagrams formed from 10 moles of acetophenone. This is CH3C double bond is said to be acetophenone, is okay. Amount of D to be depicted, how much D is formed, that to be identified. Here you have to remember 10 moles of starting material was taken, that is acetophenone. And for our convenience, all the atomic weights are provided. Hydrogen atomic weight is 1, carbon is 12, nitrogen is 14, oxygen is 16, bromine is 80. The percentage of yield corresponds to the product in each steps, parenthesis. Each step, all the products are not 100%, up to 100%. We have to consider these products as well. First of all, NaOH, sodium hypobromite, will be treated under acidified aqueous conditions and followed by ammonia. Heating is required Bromine KOH is treated alkaline bromination, we can say. Bromine 3 equivalents can be taken under glacial acetic acid condition. The brominated product you will get as the final one. Whenever acetophenone, let's see the series of reactions carried over. Whenever acetophenone is going to react with the sodium hypobromide under acidified aqueous conditions, this will be simply oxidized. The entire ketonic functional group now turned into the carboxylic acid. This is a kind of oxidation. This yield of A will be 60%. Now, acid upon treating with ammonia heating, acid derivative will be generated called amide. Amide B will be formed at the extent of 50%. And bromine KOH on amide, if you are going to treat bromine KOH, which is called Hoffman hypobromide reaction, where you are going to get any amide is there that removes the carbonyl and converted into primary amide, that is called Hoffman hypobromide reaction. This what we can say, benzamide. Benzamide is treated with bromine KOH, and which is able to give aniline as the product, and its yield is 50%. So this aniline subjected to bromination. Aniline is hyperreactive towards bromination. Bromine is also sufficiently reactive to go the highest occupation, being it is taken in the excessive quantity of 3 equivalents. Under glacial acetic acid conditions, all orthopara positions got occupied, so that you can achieve 2, 4, 6 tribromo aniline as the product with 100% yield. This is the way entire series of reactions got carried over. And after revealing the entire series of reactions and identifying the product D, the question is how much amount of D will be formed. In order to get number of moles of D, how many moles of D will be formed? In order to get the number of moles of D, the starting material acetophenone, within the problem they mentioned acetophenone taken 10 moles. 10 moles of acetophenone was taken, gives rise to the 60 percentage of A yield. 60 percentage of A yield converted into moles as 0.6, and because only 1 mole, right? So 1 by 60 into 100, that will become 0.6. And here 50%, that's why 0.5. Again 50% is 0.5. This is 100%, that's why 1 is mentioned over. 1 divided by 100 means 1 only. So that here 10 into 0.6, 0.5, 0.5 into 1, it will become 1.5. Number of moles of final product D, tribromoaniline formed is 1.5 moles. If moles are known to you, how to convert into weight? Weight is equal to number of moles into molecular weight. Number of moles are 0.5. Molecular weight of tribromoaniline will be 330. 1.5 multiplied with 330. The amount of tribromoaniline is 495 grams. This 495 grams is the correct answer for this percentage of yield. 495 grams of product will be generated over here, right? So this is the way we can go for the calculation. For question number 4, 495 grams is the correct answer. Okay. Move on to question number 5. What is the radius of electron orbit in hydrogen atom when electron is in the first excited state? Okay, this is the question which is purely coming from atomic structure. Atomic structure is the most important concept, and it is the very introductory topic in the intermediate chemistry, and which is purely relying on the problematic session. You may go with the series of lines in the hydrogen line spectral series based question will be given, or else a de Broglie equation based question will be given, or else a radius based question will be given, Schrodinger equation based question will be given. So many possible corners we can notice in the atomic structure. This is the question based on orbit and radius. Okay, in order to go for the calculation, this is the one we collected the content from Liber text, or that saying that if electron, a hydrogen atom, being it is composed of only one electron, right? It is the simplest element in the entire periodic table with the one electron system. The electron which is residing in the ground state, for example, electron is present in the ground state, Bohr's radius of the hydrogen, in order to calculate, we can use the formula 4 pi epsilon naught. h square by mv e square. So if you use all these, h means Planck constant, mass of the electron, charge of the electron, everything can be substituted, so that we will get 5.29 into 10 to the power negative 11 meters. This is a fixed value. What value it will be? It's a kind of Bohr's radius of the hydrogen. So Bohr's radius of the hydrogen whenever it is laying in the ground state configuration, that is 5.29 into 10 to the power negative 11 meters. In order to convert into angstrom, here meter to angstrom, the conversion factor is into 10 to the power minus 10. So that into 10 to the power minus 10, if you are putting, what happens, the decimal point move forwarding over here, hence it will be 0.529 angstrom. Okay, conversion factor from meter to angstrom is into 10 to the power minus 10. So here we have 10 to the power minus 11. So what you can do, cancel one 10 to the power minus 1, so that one decimal point is moving forward, 0.529 into 10 to the power minus 10 actually. Okay, so 10 to the power minus 10, if you remove, that value will become angstrom. So that 0.529 angstroms is the Bohr's radius of electron in the first ground state. That means n is equal to 1 value. But the question is, Bohr's radius in the ground state n is equal to 1. Just now we gone through the calculation. They are saying in the first excited state. First excited means electron is jumping to another level. Whenever electron is jumping to next level, that will become second energy level. Excited state energy will become n is equal to 2. In that Bohr's radius, now in order to calculate the Bohr's radius, we have the formula into r, right? So n square r into the power 2 r, here power not represented, so that you make the correction over here. Into the power 2 r can be taken here. N means in which orbital is in which orbital electron is laying, n is equal to 2 value. Principal quantum number is 2 over here, so that let me put 2 to the power 2. So this is the power value, sorry. So 2 to the power 2 into our radius of the first Bohr's orbit, just now we calculated, and angstroms as 0.529. If you take more meaningful term over here, 0.53 you can put on, so that 0.53 angstroms can be taken. 2 to the power 2, nothing but 4. 4 multiplied with 0.53, the value will be 2.12 angstroms. Whenever electron is jumping to first excited level, 2.12 angstroms is the correct value. So this is the way we can go for the calculation, 2.12 angstroms, which is given in the option number 2. For question number 5, option number 2 is the correct answer. Move on to question number 3. Sorry, question number 6, the last question of the session. It is also collected from Telangana EMSET 2023 question paper. The nuclear radius of the nucleus with the nuclear number is 16 is 3 into 10 to the power negative 15 meters. Then the nuclear radius of the nucleon with the nuclear number 128 is, right? The question purely related with the nuclear chemistry, right? So nuclear radius of the nucleus. So nuclear radius is 3 into 10 to the power minus 15 and nucleon number is 16. Second element, the nucleon number is 128, nucleus radius to be calculated. It is calculated as 6 into 10 to the power negative 15 meters. How to get this? We have to use the formula. Radius is equal to first radius a into 1 by 3 can be taken. If you go for the ratio, that means we have two radius and two nucleon numbers, right? So that radius 1 of first nucleon by radius 2 of second nucleon is equal to nucleon number of first element by nucleon number of second element whole to the power 1 by 3. This is the formula we have to utilize in order to calculate. R1 is known to you, right? R1 value is given within the problem. First nucleon number is given as 3 into 10 to the power negative 50. Second nucleon radius number to be calculated. That is unknown. Okay. So R1 is known, R2 to be calculated. A1 is the nucleon number of first nucleus given as 16. A2 is the nucleon number of second nucleus that is given as 128. Here R2 formula will become R1 into A2 by A1 reciprocated. The values are interchanged. A2 by A1 whole to the power 1 by 3. R1 value is 3 into 10 to the power negative 15. A2 value is 128. A1 value is 16. 3 into 10 to the power negative 15 into 128 by 16 whole to the power 1 by 3 can be taken. So that 5.98 into 10 to the power minus 15. This is the way you can go for 5.98 is almost is equal to 6 into 10 to the power negative 15 meters. 6 into 10 to the power negative 15 is given in the option number 4. So question number 6, option number 4 is the correct answer. By this, we completed the entire session, which is covered with the multiple components and more specific problematic session got discussed over here. And whenever we are solving the problems, then we will go for logical thinking and more enthusiasm towards the solution of the problems. And most of the things got covered with the coordination complex, how to assign the isomerism nomenclature will be there, and what kind of reagents, which product will be obtained, percentage of yield calculation for the complexes, for the organic compound, sorry. And next is about problems related with the atomic structure. So many segments of chemistry got covered over here. Hence, I can say it is a really informative session. And the question of the session will be, from the entire one, the question will be, why aniline is regarded as ortho para directing group? Let me repeat the question. Why aniline is called ortho para directing group? Why ortho para positions got substituted for further electrophilic substitution on aniline? Okay, so I'm sincerely requesting to like the channel, comment, share, subscribe, and thank you for your regular watching.